Imagine that you have followed all the rules, designed a database that meets all the requirements of the third normal form, but it still breaks. That's exactly what happened to Raymond Boyce in the 1970s, which led to the development of the Boyce-Codd Normal Form, short for BCNF. In this video, we are going to introduce you to a new normal form, the Boyce-Codd Normal Form. Yet, this video isn't just about BCNF, it's also about how one of the most elegant theories in databases turned out to have a subtle flaw, and how a young researcher caught it. Before we get to the drama, let's quickly recall what the third normal form is trying to prevent. For a table to be in the third normal form, it needs to be in the first and the second normal forms first. What the third normal form specifically requires is that no non-key columns can be transitively dependent on any candidate keys. For example, a violation of the third normal form may look like this. When a non-key column functionally depends on another non-key column, and ultimately on some key, like this. To fix a table that violates the requirements of the third normal form, you need to move the columns in the transitive dependencies to a different table, and the determinant will become the primary key in the new table. Additionally, you will keep all the columns that are directly dependent on the primary key in the old table. There would be typically a column that meets both of the two conditions, and it got to be placed in both tables, like what you see here in the example on the screen. The third normal form was developed by Edgar Codd in the 1970s. His work laid the foundation for nearly all modern database systems, for which he won a Turing Award. The development of the third normal form was detailed in his paper titled A Rational Model of Data for Large Shared Data Banks, published in the 1970s. After the paper was published, for 4 years, no one examined or challenged whether the third normal form definition was sufficiently rigorous. In 1974, a young scientist named Raymond Boyce was working through a database design example and noticed that something odd. When two candidate keys shared a column, third normal form doesn't always protect you for update or delete anomalies it is supposed to address. For example, think about a table named Teacher Course. It's a messed up design, of course, and probably won't make much sense to the real world. But it is still useful enough theoretically. The table has two candidate keys, and both are composite keys. The first one uses teacher ID and course ID, while the second one uses course ID and room. The functional dependency in the table is between two columns. Course ID depends on room. This design is perfectly valid in the eyes of the third normal form, as all the columns belong to some candidate keys, so there's no non-key columns, thus no transitive dependencies. However, if the table is populated, and when you ever try to perform an update, such as updating the room where CS101 is told, you need to remember to find all the rows where course ID is CS101 and then update all their rooms. Otherwise, you will have an update anomaly. Remember, the functional dependency between course ID and room asked you to do so. So the third normal form is not strict enough, especially the focus on non-key columns. Theoretically speaking, you can have some rogue columns that are part of a key and still gives you the trouble of transitive dependencies. Actually, it doesn't have to be a transitive dependency either. As you saw in this example, when a part of a key is functionally dependent on a part of another key, it is already bad enough to give you an update or delete anomaly. To address such an issue, Edgar and Raymond worked together to develop the Boyce-Codd Normal Form. It requires a table to be in the third normal form first. Beyond that, it also requires that every determinant in a table to be a superkey, but nothing else. The new normal form successfully fixed the loophole discovered by Raymond. If a table is not in BCNF, it would fix its design by splitting it to two more smaller tables based on the violating functional dependency. In the example that we visited, it's the course ID determining room that violates the BCNF, so we split them to two different tables, and make the determinant the primary key in the new table. The original table should only keep those columns that are determined by superkeys. Since course ID meets both conditions, it's gonna be kept in both tables. That said, I need to confess that BCNF is rarely used in real world because it's very hard to find a table that violates only BCNF but not the third normal form. However, BCNF is still valuable to database theories and the foundation of the field. The best part of this story is not just about BCNF or the loophole of the third normal form, it's about people. Edgar initially resisted the idea that his definition of the third normal form was incomplete, but eventually embraced the correction. And when the two successfully developed a new normal form that fixed the issue, Raymond's name came first in its name. BCNF may be rare in practice, but it represents something important, the pursuit of completeness, even when the flaw is rare. In this video, we started from the tiny loophole of the third normal form and explored how it was discovered and fixed, and ultimately led to the Boyce-Codd Normal Form. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.